Hey everyone, and welcome to today's Explainer. Today we're exploring something absolutely fundamental to our modern lives, yet it's almost completely hidden from view. We're talking about the everyday world of scientific research. We're going to unpack the realities of this world, drawing from a fascinating new documentary called The Endless Frontier. It was created by biophysicist Aaron Mertz and immunologist Trudy Naik, and actually recently got highlighted in Science magazine. Think about it. We all enjoy the fruits of science, right? From the smartphones we're literally holding right now to life-saving medicines. But the actual path to those discoveries? Well, it's often a total mystery. So let's pull back the curtain and see what's really going on behind those closed lab doors.
Okay, let's dive into this. Think back to the COVID-19 pandemic for a second. Suddenly, scientists were thrust right into the public spotlight. They were on the news every single night, sequencing genomes, developing vaccines at lightning speed. It really felt like just a constant stream of eureka moments. But the filmmakers realized something crucial during that time. The public still didn't really grasp the grueling, day-to-day reality of the work. That massive spotlight, that was the exception, not the rule. The daily life of a scientist isn't some dramatic, fast-paced movie montage. It's a stubbornly invisible, highly intensive grind that happens long before any headline is ever written.
And, our misunderstanding really starts with how science is presented to us when we're kids. It's usually taught as a closed book, like a finished textbook with a definitive answer key right there at the back. But the reality? The reality is an endless frontier. It is this massive, constantly evolving work in progress. It's a continuous loop of iteration, of making mistakes, and totally revising our thoughts the second brand new data comes in. It's not about memorizing answers at all. It's about asking questions that literally no one on Earth knows the answer to yet.
Section 1. The Endless Frontier, Defining the Pursuit. Now, what's really interesting about this is the massive historical weight behind those three words. The Endless Frontier isn't just some poetic phrase the filmmakers made up to sound cool. It's a direct reference to a landmark 1945 report delivered by Vannevar Bush to President Harry Truman. Bush was the principal science advisor for the country at the time, and this exact report laid the essential groundwork for establishing the National Science Foundation. The filmmakers deliberately chose this title because it perfectly captures that true, limitless spirit of discovery. Science isn't a map with hard borders. It's a frontier that just keeps expanding the further you push into it.
To bring this vast frontier to life, the documentary zooms in on three incredibly distinct scientific paths. We have Andrea Graham, an ecologist and immunologist at Princeton, Paul Barber, a marine scientist at UCLA, and Jacob George, a neuroroboticist at the University of Utah. The creators were super intentional with these choices. They wanted to showcase a really wide range of fields. We're talking everything from coral reefs to neurorobotics, and just as importantly, a wide range of geographies. There's this common misconception that vital science only happens in these elite coastal bubbles. But as Jacob George's work in Utah absolutely proves, groundbreaking innovation is happening everywhere across the country.
Section 2. The Hidden Struggles, Iteration, Training, and Funding.
So let's talk about the reality of this career path, because it is grueling. First off, you're working in a lab where, totally unlike a college exam, nobody has the answer key. You're basically in the dark, just feeling around trying to find the light switch. Second, it requires this intensely long, rigorous training process. And third, and I honestly find this detail both funny and deeply revealing, scientists are often stuck in school or training programs until they are 30 years old. Aaron Mertz actually points out that even a scientist's own family often doesn't get it. They're like, why are you still in school at 30? It takes just a massive amount of personal sacrifice and pure endurance before a researcher ever gets to launch an independent career.
And then once they finally do launch that career, bam, they hit another massive hurdle. Early 2025 brought immense, really unprecedented challenges in securing the grants required to hire teams and maintain research portfolios. The film captures researchers discussing this real existential dread of funding instability. We're talking about upheavals in federal support that don't just delay progress, they threaten to permanently shut down active research and force labs to terminate crucial training positions. This is the constant, quiet anxiety humming in the background of almost every single laboratory in the country.
And this brilliantly illustrates the core message of the documentary, perfectly captured by Aaron Mertz. He says, science is not done by robots. Yet, science is done by human beings, and they need investment. It's so easy to read about a new medical breakthrough and totally forget the actual people who spent a decade staring into microscopes to make it happen. Human beings drive this innovation. And this isn't just about their jobs, it's about all of us.
Basic science investment connects directly to our healthcare, our new tech, and our overall economic prosperity. Without supporting the humans doing the work, the entire engine just stops.
Section 3. The future of discovery. Optimism versus pessimism.
This all builds into a really complex outlook from the filmmakers. It's a stark contrast, actually. In the short term, Mertz maintains a real sense of optimism. He points out that politics goes in waves, right? With elections every 2 to 4 years, which always offers the hope of renewed national support for science. But in the long term, there is deep, deep pessimism. The real fear is that recent upheavals and funding uncertainty might permanently drive the rising generation away. Think about it. If a young, brilliant student looks at the landscape and sees nothing but canceled grants and job insecurity, well, they're going to choose a different path.
So the crucial point is this. It will potentially take up to a generation to undo the damage of stalled or canceled grants. You can't just hit pause on science and then hit play again 3 years later like nothing happened. The pipeline of human talent simply doesn't work that way. Even a few years of canceled grants means we lose brilliant young minds to other industries for good. And once that continuity is broken, once those training positions disappear, man, it takes decades to rebuild the institutional knowledge and the momentum that we lost.
I want to leave you with this final provocative thought. If the next generation looks at the struggles, the relentless funding cuts, and that decade-long training period, and decides to abandon the frontier entirely, who exactly will make the discoveries of tomorrow? Who's going to cure the next pandemic, or invent the next clean energy source, or map the depths of the ocean? Science is a profoundly human endeavor, and it absolutely requires our support to keep pushing forward. Thank you so much for joining me for this explainer. Keep asking questions, keep looking behind the curtain, and I'll catch you next time as we continue to explore the fascinating world around us.